Bismillahirrahmanirrahim. Mrs. Sobia Suhail is here with complex numbers. In the last videos, I have explained about the addition and subtraction of the complex number, and in this one video, I will explain about first the multiplication and then division with complex numbers. Okay, and in the last, representing and then expressing in the form of a plus iota b. This is the standard form of the complex number. When we are solving the complex number, so it is compulsory that we have to represent the last of the complex number in the form of a complex number. Okay, so finally the answer, whatever the form of the answer is, we have to transform that form into a complex number. Okay, so let's take this one. A few examples I have taken from the unit number 2 of 9th class 9th. Exercise is 2.6 and this is the question number 4. I will take a few parts from this question. That here it's given a question like -7 plus 3 iota and it is multiplied to other number. Let me change this number a little bit. I don't want to keep the same number as it is. You must remember about the rules that how to multiply. We will multiply, think that these are two terms, these are also two terms. Normally how we are expanding, we will expand this in the same way. Expansion will be done like -7 multiplied to complete -5 plus 3 iota plus 3 iota multiplied to complete -5 plus 3 iota. Okay, after this -5, 7 and -5, if you multiply it, negative and negative number multiply to give a positive number. 7 5s are 35, minus plus minus, 7 3s are 21 iota, plus minus minus, 3 5s are 15 iota, plus plus plus, 3 3s are 9 iota square. Okay, let me put the iota sign properly, because if you will not keep it properly, you will do the mistake by your own self. So make the iota sign properly. Okay, now this is a complete constant term. This term have iota, this term have iota, this term have iota square. Keep in mind, as I told you that in the last video, iota square, wherever you see iota square, keep its value or substitute it with the value of -1. 3 dots means, as you know before. Okay, so we will add these two terms together. 35. No. Solve the like terms. Sorry, my kids came in my room. So -21 and -15, they will add up, digits will add up in negative integers and sign will remain same. 5 plus 1 6, 1 plus 2 3, iota will also kept same, plus 9 times iota square means replace its value, that is -1. Now if you see, this is a constant term, this have iota, this plus minus 9, so this will also be constant, -9. -36 iota you can keep here. After that, these two will be solved together. 5 minus 9 will be equals to 36 minus 36 iota, and it is transformed in the form of a plus b iota, that here a is equals to 26 and b equals to -36. Better keep this answer in the last as it is. Okay, this part is solved. Multiplication is done. After this one, the next part I will solve Second, if it is not changed form of iota, if it is not given form of iota, then how to transform the question form of iota first. Okay, check one number, minus 4 under root. You can write this number in the under root as minus 1 times 4. So we put the square root of both into separate 4. So it will make minus 1. Iota square you said minus 1. Before that we proved that taking square on both, iota will be equal to minus 1 under root. As we know before, minus 1 iota, this is iota, and this answer of this will be 2. So it becomes 2 iota. I explained this in the detail so that there should be no any confusion that how it transformed like this one. So 2 minus under root will become iota, and 4 will be 2. I will write 2 in the start. So 3 minus 4 will become 2, will come out of the square root. Minus 1 in the square root will become iota. Now we will multiply in the same way. 2 times 3 minus 2 iota, minus 2 iota times 3 minus 2 iota. And from here you can continue the question. Next number is number 3, under root 5 minus 3 iota square. Square means that you can write the same number 2 times or apply the algebraic identity. Whatever you want, you can that one. Under root 5 multiply under root 5 minus 3 iota and minus 3 iota under root 5 minus 3 iota. Under root 5 multiply under root 5, it become under root 5 square, 3 under root 5 iota. Then plus minus 3 under root 5 iota, and minus plus 3 3s are 9 iota and iota square. Okay, become 5 minus 3 times minus 3 times. It means the coefficient will be added. Minus 3 times this, minus 3 times means minus 6 times under root 5 iota. Plus 9 iota square will be replaced by minus 1. Now 5, this is minus 9, minus 6 times under root 5 iota. So 5 minus 9 minus 4 minus 6 times under root 5 iota. So it is completely in the form of a complex where here A means term is real part is minus 4 and B means imaginary part is minus 6 root 5. Hence the multiplication I have explained properly. Hopefully you can understand that how to continue. There is one more part is so it's better that I can explain that also till you can understand. Till then I will explain. The part number 4, it is written as 2 minus iota, 2 minus 2 iota conjugate. Conjugate, as I already explained to you that in the conjugate the sign of the imaginary part is changed. So when we apply the conjugate on the number, the sign of the imaginary part changes to 3 plus 2 iota. Now it's a normal number. You can multiply as the same applies the rule of multiplication. 2 times the complete term minus iota times the complete term. You can continue. Then division. Dividing by a complex number. Okay, we can or simplify this. First question here, it is minus 2 over 1 plus iota. In my last videos also, I've explained one time that whenever there is a complex number in the denominator and you have solved that further, you need to do the rationalization. Okay, so rationalization means I will write rationalization here on rationalization. what you are doing in this process? In this process, you multiply the conjugate of this complex number, multiply and divide. Means multiply and divide conjugate of this. Conjugate means the sign of the imaginary number will be changed. Real number remains same and imaginary will become negative of it. Real part remains same, imaginary part will become negative of it. Means same complex number, multiply and divide, the sign of the imaginary part will change. This process in the complex number is called rationalization. It has to be done when you want to simplify denominator and change it in the form of numerator. So minus 2 times this complete. We can put the bracket minus 2 times 1 minus the downside. If you see the terms, first term same, second term same. Second sign are changed. A plus B, when multiply A minus B equal to A square minus B square. This formula should quickly come into mind that we can apply this algebraic identity to for the further simplification. Here first term is 1 square minus second term is iota. Meanwhile, we will simplify the numerator also. Minus 2 ones are minus plus and times iota divided by 1 minus iota square replaced by minus. Minus plus iota divided by 1 minus plus 1 become. Now this denominator will be shifted to both. If you keep from here this 2 it is, that can also give you the answer, but if you solve still you can give the answer. This 2 will be given to both separately. This is cancel. Cancellation mostly I prefer to do with the pencil or color pen. They cancel one time. So this is equal to minus 1 plus iota. Here again real number is minus 1 this and imaginary is coefficient of iota, that is 1. So in this way the division is solved. I will give more examples for clearing this concept. Second part I write in which a normal number is the complex number is in the numerator and denominator. Again I am telling you, whenever you have a complex number in the denominator, you have to do the rationalization. Conjugate of this number will multiply and divide. This is rationalization. Rationalization. One multiplied to each other or one multiplied to each other. When complex number multiplied to complex, as I told you in the previous video, what happened that 2 times this number will multiply, there is a proper result. So if that is difficult to keep in mind, multiply like the method. 2 times 4 plus iota plus 3 iota times 4 plus iota. Downside again a minus b into a plus b. So a square minus b. Okay. 4 are 8 plus 2 iota plus 3 are 12 iota plus 3 iota into iota square. 4 are 16 minus iota square. You can replace at the same with the minus 1 also. That is more better. 8 iota and iota, they are like terms, so we will solve them together. As they both are positive, so let them plus 14 iota and plus 3 iota square replaced by minus 1. Downside also iota square replaced by minus 1. Whenever you are changing it with minus 1, I am doing a short step. This is negative 3. When you will solve, it will be negative 3. Minus 3 is positive 5 plus 14 divided by 6 minus plus 1 will become 17. It's solved completely and it becomes real number. So distribute this real number to both the terms. Means 5 divided by 17 plus 14 divided by 17 iota is completely transformed to a complex number. And here, what is the value of A? That is 5 by 7. And what is the value of B? That is 15 by 17. It is completely solved. Next question is that if you have more than one terms, then how to solve that one? Number 4 part I'm doing. Third is same to same like this. You can do the practice of that. Here is a question given with 2 minus 6 iota over 3 plus iota, and then minus 4 plus iota divided by 3 iota. Okay. Luckily, denominator is same. Otherwise, if the denominator is not same, we have to make the denominator same and then solve the next fractional part and do the next solution for the question. Here, denominator is same. We will write one time and collect the numerators. 2 minus iota minus 4 plus iota. Put the bracket to avoid any inconvenience because minus is in the cell, so minus every time changing the sign. So avoid any mistake, put the bracket. Now open the bracket. 2 minus iota minus 4 minus plus minus iota over 3 plus iota. At this step, until we are solving the numerator, we will do the rationalization also. 3 minus iota and 3 minus iota. Okay. Now solve the like terms. 2 minus 4 minus 2, and then minus 6 and minus 1 minus iota. Single term, multiply by 3 minus iota. Divide by a plus b, a minus b means a square minus b square. Now upper one multiply. Multiplication is same, minus 2 times 3 minus iota and minus 7 iota times 3 minus iota. Divide by 9 minus iota square replaced by minus 1. Minus 2 3s are 6, minus minus plus 2 iota, minus 7 3s are 20 iota, minus minus 7 iota 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 square. 9 plus. These are two like terms with single iota. Okay, so minus 6, when you add them, they have opposite integer. So opposite integer always subtract. 21 minus 19. Sign of the big value used, variable remains same. Plus iota square replaced by minus 1. 9 plus 1, 10. Minus 6 and this will be minus, plus minus minus. 7. 19 iota right in the first over 10. So this one will be solved as minus 13 minus 19 iota over 10. So give the denominator to both the numerator part like this. So it's a complete one complex number, and here A is minus 13 by 10 and B minus 19 by 10. And in this way, this question is completely. There are many ways of solving these of the question. So no hard and fast rule that you can use on specific steps you use, or you can continue with any way. There is one more thing. One more question is there with 1 plus iota or 1 minus iota. There is a square on. Take the square of both. Then check what happened. Square of the first term, a square plus b square 2 times a and b divided by a square plus b square minus 2 times first term and second term. 1 iota square change to -1 plus 2 ones are 2 iota. 1 iota square change to minus 2 ones are 2. 1 plus -1 they give 0. Means if you open 1 minus 1 plus 2 iota, it's up to you, or otherwise still it is clear that they will cancel each other. 1 minus 1 cancel 0, 1 minus 1 cancel 0. Upper one left 2 iota, down one left minus 2 iota. So this cancel -1. As the imaginary part cancel, so you can write this in the form of iota 0. So here A is to -1 and B was getting 0. That's why the imaginary part of this question is 0. In these type of the parts, when there are more than one term of a complex number, more than one complex numbers are there, you cannot start rationalizing until they leave single a single complex number. So make a single complex number form. Whether you can multiply here, write down the step here, or whether you can continue multiplication here and continue as it is. As like I would like to prefer multiply them here, that 2 times minus iota and plus 3 iota times 1 minus iota. It will take you less. Okay, I will start over here. 2 minus 2 iota plus 3 iota minus plus minus iota square. You have to keep your in mind that your writing must be clear at least to you, that you should understand what you are going to write. 2 3 is 2 1 iota. 1 iota means 1 iota. Minus 3 times iota square means -1. Writing is very important in maths, that you must not confuse yourself and the checker also with your symbols, your writing, your numbers. Everything should be clear. Minus plus 3 1 3. 3 plus 2 5 plus iota. Keep this in the separate box. The answer of this whole is 5 iota and it takes less. Okay. Now we put, instead of, we will put its answer 5 plus iota, and on this we can do rationalization also with the conjugate of this number. So we save our space and we save our time also. 5 minus iota multiplied will remain same, and downside a plus b, a minus means a square minus b square. Now numerator 5 minus iota, denominator 25 minus 1 will become 26. So divide both the terms with 26, or you can write 5 by 26 minus 1 by 26 iota. That you can tell properly that here a is equals to 5 by 26 and b is equals to minus 1 over 26. Until now, I think my lecture for multiplication of the complex number and division of the complex number is completed, and I have explained each and every step, the complete detail. In most of the cases, I have also explained that how to continue the simplification with the complex number. Now you must be good with the addition of complex number, subtraction, multiplication and division. Okay, in the next video I will continue the properties on complex number, inshallah. Okay, thank you so much.